Acids and bases. These are something that chemists have known about for quite some time, but there are some rather famous definitions of each of these, and it's still somewhat debated on what the definitions are and what might be the best definition to use in one particular case over another. But these are the most prominent definitions, and we'll familiarize ourselves with them. So we'll start with the least broad definition, and that is the Arrhenius definition. And simply put, an acid in the Arrhenius definition is something that dissociates into H plus in solution. So it directly and for a base it will generate OH minus. So this is for the acid, this is the base. So same thing, directly makes, but in this case it makes OH minus for a base. This is somewhat limiting though, because there are some bases that we know that do not contain OH minus in their formula. Now, most of the strong bases do, certainly if you stay inside of more inorganic terms. But that is limiting. And we know that there are more bases because there are substances that react with acids and to create a neutralized solution that don't have OH minus or hydroxide in the formula. Similarly, there may be some substances that don't have H plus, but we'll have to move on to a different definition to get there. Next, let's talk about Bronsted-Lowry acids and bases. This still needs H plus to be involved, but this is thought of in terms of protons. So H plus. An acid is something that donates a proton. So proton donor. And conversely, a base, it would be the opposite of that. It would be a proton acceptor. This opens up the definition a little bit because now a base no longer needs to have OH minus in the formula or hydroxide. It only needs to react with protons. And that has broadened the definition a bit. And we can broaden the definition even more by talking about Lewis acids and bases. Now, if you remember, we have drawn Lewis structures in our chemistry class before. And so you might take a guess as to what these are about, and that is electrons. Yes. A Lewis acid is an electron pair acceptor, and a Lewis base is an electron pair donor. So I'm going to just write that here. Base is an electron pair donor. An acid is an electron pair acceptor. I used to have trouble remembering which of these is which one goes with the base and which one goes with the acid. And then I thought about the simplest acid I could think of, which is H plus. And H plus simply does not have any electrons. And so it cannot be the electron pair donor, so it must be the electron pair acceptor. And so that's kind of one of the ways that I remember which is which. It's more ingrained in my mind now, so I need that less, but it is something that you can fall back on. You just need to remember that Lewis acids and Lewis bases involve electron pairs. One of them is giving them away, one of them is taking them. And then if you remember H plus is an acid, then you'll be able to figure out which one can give away electrons and which one can't, because there's no electrons in H plus.